Consider this. You're a wastewater treatment plant operator and you're making the rounds first thing in the morning until you realize your aeration tanks are black. Your effluent, it looks terrible. You could take a sample now, but would you really capture what actually happened? That's exactly what the Evansville West Wastewater Treatment Plant is trying to do to solve its industrial pre-treatment woes.
Two probes, one on the water coming out of the grit removal system and one leaving the primary clarifiers. So we call one influent, one effluent. We can basically set where our alarms are, like how concentrated is too concentrated and how dilute is too dilute. We've really been able to fine tune it so that whenever we get an alarm, we know it's real.
Yet the testing, results, and iteration involved in adopting and using these real-time CBOD5 sensors are emblematic of the Evansville Water and Sewer Utilities' efforts towards continuous improvement. Constructed in the mid-1950s, the Evansville West Wastewater Treatment Plant receives flows from 31% of the city's collection system. Pigeon Creek divides the city into two different watersheds with 900 miles of sewer, 421 miles of which are sanitary.
We serve about an estimated population of 180,000 people. And one of our biggest issues we had in the past would be with storm sewer overflows or having, manholes popping off. We did increase our influent wet well depth to increase the sewer velocity for overflow reduction. And then we have that CSO tank, which can hold 6 million gallons of water, and that takes a big load off of the sewer system.
In the 1970s, the plant added a conventional activated sludge system, and in 2009, it added a biologically aerated filter system, which also assists the utility with handling some of those stormwater flows.
We actually worked with Crew and implemented a program type that, based on the influent flow, adds and subtracts cells. So if we get a rain event, then it'll bring more cells on. If we're in, July, then we're not going to be running all 12 cells. We actually run 8 cells at a minimum.
In the BAF system, millions of 1 millimeter in diameter polystyrene beads fill the tank.
The water flows upwards through them and is aerated, and they get pushed up against a concrete deck with nozzles in it. To once it's been introduced to that biological media and it's had time to establish, they'll actually filter and reduce soluble contaminants like ammonia too.
At the end of the process, the plant uses ultraviolet disinfection before discharging to the Ohio River. This does create its own set of challenges and complications, but it's once again a place where we can notice that the plant personnel has an attention to detail to ensure optimization of every process to create the best possible effluent that can be.
UV is great because of the safety factor there. You're not dealing with chlorine gas or hypochlorite. But the bad thing is if your particle size is too large in diameter, bacteria can hide out and make it past the screen. So that was something that we realized was happening because of overcapacity.
That won't be the end of the experiments either, as there's more capital improvements on the way, one of which will help the utility with its sustainability efforts and perhaps even help its bottom line.
Right now we are kind of under construction. We're having a cogen unit put in. It's a gas core biogas CHP container package from Craft Power, and it's a 607 horsepower engine, and I think it said it could produce up to 436 kilowatts. That will actually run on conditioned biogas that's generated from our digesters, which will have a unison gas conditioning skid, which will help remove all the harmful contaminants prior to combustion. So then we'll use cooling water heat that's recovered to help maintain our digester temperatures, and we're looking forward to hopefully, producing half of our total power consumption.
Whether it is the continuous monitoring and future improvements of the real-time CBOD5 sensor system, the construction of a 6 million gallon CSO tank, the adjustments and iteration of its BAF system, or even the introduction, in the future, of a cogeneration unit for combined heat and power, it's pretty clear to see that the Evansville Water and Sewer Utility is in great hands. If you liked this video, then hit the like button down below, and while you're down there, if you wanted to learn more about the plant, you could check out the description, in which there is an article that goes into much greater detail, and while you're there, make sure you hit that subscribe button too. Everything all helps out in the end, and we'll see you at the next one.